we are interested in evaluating the following integral. The integral of dx divided by square root of 4 plus x squared. Regular substitution doesn't work for us here. What are we going to do instead? We're going to use trig substitution. So in trig substitution, what are we going to do? Since you have 4 plus x squared on the denominator, let us use x to be 2 tangent of theta. Why is that? Because if I look at my denominator is square root of 4 plus x squared. So if I just substitute 2 tangent theta, I have 4 plus 4 tangent squared of theta. I can factor out 4. I end up with 1 plus tangent squared of theta, which is familiar to me. I already know this guy is equal to secant squared. So this integral with this substitution helped me to simplify my denominator to 4 times secant squared of theta, or 2 times secant of theta. So let us go back to our integral. This integral so far has denominator 2 secant theta. What about dx? Dx is equal to, well, you have 2 tangent theta. It becomes 2 secant squared of theta d theta. So my dx is 2 secant squared of theta d theta. So you can easily get rid of 2 and 2. One of the secants disappear, and you end up with the integral of secant theta d theta. How do we calculate the integral of secant theta? To calculate the integral of secant theta, secant, as you remember, is 1 over cosine theta. What I'm going to do, I'm going to use a trick, right? I'm going to multiply this by cosine and divide by cosine. This is basic algebra. Let us multiply the numerator by cosine and multiply the denominator by cosine as well. Now what? Now this integral can be written as the integral of cosine theta d theta divided by cosine squared of theta. But cosine squared is 1 minus sine squared of theta. On the numerator, I have cosine theta d theta. I can go back to elementary calculus and use regular substitution. What substitution? I'm going to take u to be sine theta, and my du is cosine theta d theta. So this integral is equal to the integral of du divided by 1 minus u squared. So how do we calculate this integral then? This integral can be calculated using partial fractions that we discussed in our class. So in the method of partial fractions, if you have 1 over 1 minus u squared, this can be written as 1 over 1 minus u times 1 plus u, which in turn can be broken down into two fractions, a divided by 1 minus u plus b divided by 1 plus u. Our goal is to find the value for a and b. If you take common denominator on the right-hand side, you have 1 minus u times 1 plus u, and you have a times 1 plus u plus b times 1 minus u. The combination on the right-hand side must be equal to the fraction on the left-hand side. But note that the denominators are the same. We just need to find the numerators. So far we have a times 1 plus u plus b times 1 minus u equals to 1 on the other side. Remember the trick that we used. If u is equal to 1, then you have 2a plus 0 equals to 1, or a is a half. If you use u to be negative 1, then you have 0 minus 2b equals to 1, so b is negative a half. Let us go back to our integral. This integral can be written as the integral of a half divided by 1 minus u plus negative a half divided by 1 plus u du. We found the value for a and b, and we substitute them into the partial fractions. These two are easy to work with. Why is that? The first integral is a half integral of du over 1 minus u. The second integral is negative a half the integral of du divided by 1 plus u. The first integral is negative a half ln of absolute value of 1 minus u. The second integral, negative a half ln of absolute value of 1 plus u. What was u? U is the sine theta that you have. So this integral in terms can be written as negative a half ln of absolute value of 1 minus sine theta minus a half ln of absolute value of 1 plus sine theta. Perfect. Don't forget the constant of integration, but now we need to go back and write everything in terms of x, because our original integral is in terms of x. But what substitution we used? We used x equals to 2 tangent theta. So since x is equal to 2 tangent theta, what's the meaning of that? It means that tangent theta is equal to x divided by 2, or from the right triangle that we had, this is x, this is 2, and this guy is square root of 4 plus x squared. Very good. So sine theta can be written as x divided by the hypotenuse, which is square root of 4 plus x squared. So this integral in terms can be written as, we can factor out negative a half and combine these two as well if you want to. Absolutely fine. Or leave it as negative a half ln of absolute value of 1 minus x divided by square root of 4 plus x squared minus a half ln of absolute value. Let me just move this a little bit down here. Don't want this ln of absolute value of 1 plus x divided by square root of 4 plus x squared plus constant of integration. The rest is simplifying ln as much as you can. Because if you factor out negative a half, you have the multiplication, you have the addition of two ln that can convert into their multiplication. So let me show you. So the rest is algebra. From algebra, you can factor out negative a half, and you have ln of absolute value of 1 minus x divided by square root of 4 plus x squared plus ln of absolute value of 1 plus x divided by square root of 4 plus x squared plus constant of integration. But remember that if you have ln of a plus ln of b, ln of a plus ln of b is ln of a times b. So this is your a and this is your b. You can combine these together into one ln. You have negative a half ln of, here if we assume all of these quantities are positive, we can get rid of the absolute value to have a simpler version. You get 1 minus x divided by square root of 4 plus x squared times 1 plus x divided by square root of 4 plus x squared plus constant of integration. But remember that here, if you multiply these two quantities, then you have a minus b times a plus b. It is a squared minus b squared, right? Your a is 1, your b is x divided by square root of 4 plus x squared with opposite operation in between. So you can combine these two and you have negative a half ln of 1 minus x squared divided by square root of 4 plus x squared to the second power plus constant of integration. So this guy in turns can be written as negative a half ln of 1 minus x squared divided by 4 plus x squared. If you take common denominator between these two, you get negative a half ln of 4 plus x squared, 4 plus x squared minus x squared plus c, or you have negative a half. You can cancel out these two terms. Negative a half ln of 4 over 4 plus x squared plus constant of integration. So in a shorter version, and here on top, you have the longer version with ln that are not combined together. So let us go over summary together. So here we had a simple integral of dx divided by square root of 4 plus x squared. We used trig substitution of 2 tangent theta, right? When we use 2 tangent theta, we could simplify the denominator to 2 secant theta. And since dx is 2 secant squared d theta, you could simplify the numerator and the denominator. But we end up with the integral of secant theta d theta. To calculate this integral, this is a special case. What you can do, you can multiply and divide by cosine theta to create 1 minus sine squared on the denominator and use regular substitution. In our regular substitution, u is sine theta, du is cosine theta. So you have the integral of du divided by 1 minus u squared. So from trig substitution to regular substitution, then we apply the method of partial fractions. 1 over 1 minus u squared can be written as a half divided by 1 minus u, plus negative a half divided by 1 plus u using partial fractions, everybody. So this is another technique that we use to calculate the integral in u. What was u? U was sine theta. So we substitute this guy back. But since our original integral was in x, we have to change everything to x. Since x is 2 tangent theta is x divided by 2. By definition, it is sine over cosine. You have x and 2, so you get the hypotenuse, which is 2 squared plus x squared inside the square root. So sine theta is equal to x over hypotenuse, which is square root of 4 plus x squared. You substitute everything back for sine theta, and then you can leave your answer like this, or you can use the properties of ln and simplify this guy further. Then take common denominator, simplify this more, and you can write your integral in this form, or you could flip this as well. For those of you who know and feel more comfortable about this, you can write this as ln of 4 divided by 4 plus x squared to power negative a half plus c. But this guy can be written as ln of 4 divided by, let me just switch this because you have a negative exponent, 4 plus x squared divided by 4 to positive a half plus c, or you get ln of square root of 4 plus x squared divided by 2 plus c. This is simpler than the previous one. But again, for those of you who feel more comfortable about ln and doing algebra, I highly encourage you to take a look at your answers.